Welcome everyone to today's more live stream. Just what you signed up for and you get it. Breaking news holds the press. zstd brings even better compression and decompression performance. Something we are certainly interested in. And I need to do the T2 morning updates anyway. So here we are. And then I opened this. I actually did not read this news here fully and thought got already happy and whatnot. But then I looked over this here, the zstd announcement here, and unfortunately it is not as amazing as this news made it sound. So much to always reading the fine print, because here zstd fastest compression level just got faster, so it sounds like only the fastest compression level, not all, at least. Otherwise, I think they would have written here, everything gets 6 to 8% faster. Although, to be fair, in this news article, it's also written first brings even better compression, decompression performance, but then fine print should now be faster in most scenarios. Oh wait, what? With the fastest strategy? So you're not really sure who is using that, except maybe in the Linux kernel, and there it needs. But there you also see some notes. So first of all, this news not as amazing as I first thought. So this is also lesson learned, always read the fine print. Let's update it anyway, because every update certainly usually is amazing. And of course T2 updates, just update package zstd this or with a 0. Also, I don't like when news, can they not have a 0 in here, that you have the precise number, whatever. But at least for me, for copy and pasting it. And also in other news, but then we continue with both a minute more, because here valgrind is out. Valgrind, of course, is this amazing machine code, C, C++ and other development tool for analyzing memory and cache access and such, and is a super invaluable tool for working with C and C++, finding memory issues, off by one, out of bound, out of array, other cache analysis, cache misses and whatnot. Completely amazing, ingenious tool here for all of those who probably, most of my audience probably knows this already. If not, then probably something you definitely want to look into. Of course, here the T2 updates, super simple. Just here this update package thing, and if you are using T2 and want to contribute, can always drop in an email of update notes, or if you want to do this already, send in the change set here by mail and such. And some more notes. So first of all, yeah, read the fine print. Second of all, by the way, they have here, we could compare. So here you see, by the way, that apparently C-lang is slightly slower also for our C-lang benchmarking. So much to amazing performance of C-lang and GCC, and maybe not. And the second thing is, with what I said in the microkernel argument, here with this you need to port this again to the Linux kernel, because the Linux kernel has zstd and even grub. There you see the drawback of bootloaders and monolithic kernels. Now they need to always forward port this to the more constrained environment of the C and monolithic thing of the Linux kernel, because you don't have the regular memory allocation and other library routines. The same for the bootloader. Obviously grub2 has this as well. Why do they have this in the Linux kernel? Not only compressed initRD, but also zstd. So this is why the Linux kernel and grub have copies of this. Obviously in this monolithic world. This is where my ideas come from, to also use the microkernel, our new hobby here, that we probably eventually continue. Also zstd compiled. Why is this so slow here? How many drop frames? Hey, 0 drop frames. Our SSH tunnel still works wonders. So committing this as usual here. Ah, wait a second, have I committed some? Anyway, okay, now then we build with LZ4. Anyway, not the most important for me. So much to another lesson learned, always look for what you are committing for straight changes, but whatever. Not that interested in that anyway. Valgrind. And also Did I make a typo there? Oh, I think I made a typo there. Because somehow this is laggy with valgrind, with all the traffic going through one SSH tunnel for UDP cable DOCSIS reasons. And also the next, so not only set standard, this is why both of them are an accidentally, coincidentally nice topic here, because not only if it with one microkernel as a bootloader, because as I said in the grub2 case, not only set standard but also all the file system code, and even I saw in grub2 and these are those kinds, of course, grub2 is a huge monolithic monster, just like systemd, or I still wait for the day that systemd takes over the editor. I'm sure they can also integrate an Emacs editor in there and a monolithic kernel, and then closing full circle there in the systemd department. But not only set standard and stuff, also I set it already file systems, all the X2, 3, 4, riser, BetterFS, XFS, JFS or whatever, FAT, everything is duplicated in grub2 and also to some degree in legacy initial grub version 1. And the second thing is also additionally other drivers. For example, I've seen in grub2 not only do they have Morse code stuff for the PC beeper or what, seriously, is anyone ever really asked for this? If something, I would use a serial console and not a Morse beeping PC speaker, but whatever. It's there for those who, all of you who were waiting for Morse code beeping your bootloader. But another thing is, of course, other drivers like not only network drivers in grub2, but even seriously a serial USB dongle thing, PLC something, whatever, in my opinion, slightly getting out of hand there. And there is precedence of using a kernel to boot other stuff. We do this with the Linux kernel as well. On the PS3 and other, maybe even IBM P series, there is Petit Boot, which is a Linux kernel with some initRD glue for on the PS3 and such, loading the Linux kernel as a bootloader and then loading your actual kernel. So on the PS3 you always have this vintage Linux kernel as bootloader thing, and then only then continue with kexec, this kernel executing another kernel. So no reason why we cannot just do away with the bootloaders and in general have our microkernel thing have only one set of drivers, one set of file systems, one set of compression algorithms. Does that not sound amazing? Maybe, I hope, and a nice hobby to pursue. And the next thing here with a similar topic, you can't just valgrind, because valgrind is really amazing. I often have used this, not only in exact image, but also our OCR and other fun stuff. And this is really good at finding memory issues, accessing out of bounds and all kinds of other fun stuff. Use of uninitialized data, even uninitialized variables, super amazing stuff. And with a microkernel setup, you could even run valgrind on your drivers, because the drivers are user space. And if we would port this and make this all work, then you could even valgrind your network stack and stuff like this. Is that not amazing? And fun fact, once I worked for, did some consulting, external work, so not directly work, but Exacode was contracted for some security business, helping there some firewall manufacturer, and they even had firewall code, like really advanced filtering, advanced and patent pending firewall filtering code in the Linux kernel, and they had plenty of by one, because at one point I said they had patent pending and then really naive linear iteration over all of their filtering algorithms, and they wanted also, among other things, better performance, and was not really there for performance, but some of the performance guys were maybe I should not say something to that. Anyway, I had then an amazing idea to not linearly iterate over these algorithms, but have there some filter like file magic criteria when to run them, that you would not have a ON or something, big O notation, but a more speed up algorithm, not to call all of them, and only when some magic values at the end or beginning match already. It certainly improved performance significantly. And then, however, there were some crashes, and they blamed me for my optimized algorithm thing there, pre-matching thing, and it turned out I debugged this and said it cannot really be. I don't find really a typo in there, And then I have actually written code to have this run in user space, because then you can just, you crash a user space binary, and I was replying TCP dumps there on the user space, filtering stuff that they usually only have done in kernel. There you see, by the way, nobody ever there had the idea to do this, and it required me to come around and do this there for them. And then I could very easily, within 10 minutes, pinpoint it to a filtering algorithm of them that had off by little issues there, and so much to running everything in one address space and one monolithic kernel, especially all your network stack and firewalling. Totally amazing. Maybe not. So yeah, some morning updates, valgrind, zstd, you name it. Just a breaking news update of today. And what is new? So zstd, you have seen API stuff. Actually, I closed it already, GitHub there. And yeah, they also have some advanced API, but I'm not really sure if any one of you is using these new features, whatever details of the changes, if you are interested. And valgrind, and by the way, are we interested? Because of course we switched to zstd, because zstd has really amazing decompression speed. For the last 15 years we were using bzip2, and it is really noticeable because bzip2 is really slow. And then when I built your Linux kernel, it took already maybe a minute or something, even on a multi-thread system here like an AMD Ryzen, Threadripper, Epic, whatever. It really takes quite long, even in tempfs, to extract here this, what was the Linux kernel, was it gigabyte or some gigabyte maybe, right? If I'm not mistaken, something like this. This really took like a minute, or I don't know, over a minute to decompress, and with zstd it compresses significantly in the ballpark of 10 times faster or something. This is really noticeable when you debug large packages, build and debug and stuff in T2. So huge performance impact, especially because decompression is really super fast, and zstd completely amazing. And then here valgrind, there is some news here also if you're interested in this. They have a new tool that is now thoroughly overhauled, improved, and given a GUI as a result. It has been promoted from an experimental tool to a regular tool. Amazing stuff, whatever that is, no idea. Maybe they should have written it here in the summary. They have not used it, but otherwise, cachegrind, callgrind, you name it, memcheck, and leak something. What tree? Free tree leak, yes. Leak results in X3 format, whatever. And lots of other changes and fixes, even PowerPC 64 for our IBM PowerPC. Goodness, I hope you enjoyed this quick summary, because you signed up for more live stuff, and that is what you get here then. And thank you everyone for subscribing here. We have now 66 folks here or something, completely amazing. Yeah, 66 subscribers, only 34 short of being able to use the next features here. So would be completely amazing if you can share, like, and subscribe, because it would be amazing if we unlock here more features of the more live stream. That's it for today from this stream. Hope you learned something. Stay awesome, and don't forget to share, like, and subscribe, and I hope to see you soon for all the next random live streams to come.